So now in this video we're going to look at using the Trimpot. Trimpot stands for trimmer potentiometer. Here's a 10,000 ohm Trimpot. This is a 1,000 ohm Trimpot, and this one you can tell its value. It pops into the board a little tougher than this one. This one pops right out. That one plugs into the board a little better. So that's actually a B, not a 3, but part of it worn off. And then 1022. So the B means that it's linear. There's a steady resistance across the resistive path, and the 10 is the first 2 digits, and then the 2 there is the multiplier. So ultimately that's the number of zeros that follow 10. So 1000 1000 ohms. And so that's the resistive element across there, its resistance. And that plugs into the board pretty well. And depending on how far this is turned, so both of them are turned about halfway right now. You can see the arrow there, and this one's turned there. They're set about halfway. So let's zoom back a little. Oh, we have the fixed resistors here. The last video I did, we looked at voltage dividers with fixed resistors. So when we pull back, you won't see the leads as well. You can see that these 2 resistors are connected right there, and then those 2 resistors are connected right there. This one comes to the positive rail, that one comes to the negative rail. So basically we have 3 series resistors from the positive rail to the negative rail, which looks weird, as I mentioned in the last video, until you realize that usually you attach something there to sense the voltage. So since this is 3 resistors in series, if we connect towards the negative side, so there's 1/3 of the resistance on the negative side, we have 1/3 of 5 volts. And if we come over to here where these 2 resistors connect, now there's 2/3 of the resistance towards the negative rail, which is where we usually end our circuits. And now you can see we have 2/3 of the power supply voltage. So now the Trimpot, or other potentiometer, as I said before, Trimpot is short for trimmer potentiometer. So there's larger ones that are made to be adjusted more often, and they got bigger knobs and stuff. This one doesn't even have a knob. And these are smaller ones. They can go into the breadboard. Their pins are bigger though, so you might want to file them down or whatnot, but they'll still plug into the breadboard, all the ones I have anyways. And so I usually reserve these spots for the trimmer potentiometers, because once they stretch the breadboard, the leads from resistors and other components don't tend to go into those same spots as well. So just briefly mentioning that. But in any case, we will look at the voltage of these. So just like the resistors, one side of the Trimpot is connected to the positive rail, the other side to the negative rail. And since the multimeter really doesn't draw any current, which is actually very good for voltage dividers, you don't really want to draw any more current than you have to out of them. There are exceptions, but usually you have that voltage. You want that voltage to stay firm, and so putting a resistance to the negative rail pulls that voltage down. But in any case, these are both set about halfway. You can see it's not exactly half because it's not set exactly halfway, but it is pretty close. And that one's a little more off. We can quickly, in this case, turn the dial. So now I turned it down towards the negative rail. We know that the voltage went down. And there it's only 0.4. Remember, it stops right here, so it doesn't go all the way to the middle. It stops right there, so we're close to the end right now. And then if we turn it up, so we're almost all the way, and there you can see the breadboard likes to pop those out. So probably didn't help that I was leaning on the breadboard somewhere, but this one is in firm. So let's get back to it. I turned it up that way, I think, or did it pop up before the, yep, I turned it almost all the way to the positive rail, and we can go to the positive rail. So there we go, it stopped turning, so that's as far as it goes. So it goes to about that corner there. So we have all this movement where it does not move. It goes from there to there. So that's an idea to keep in mind. So there we go. We have the full power supply voltage, and I'll turn it all the way down. Now it's to the negative rail. So basically I'm connecting, the wiper comes over here. So basically it's just like me connecting the two probes like that for the most part. And then so this is the same, but it doesn't have a dial. And we can zoom down so it's a little easier to see what's going on there. So also, I turn that by hand. There's also a little notch here for the screwdriver. That might make it easier to see. There we go. And then this one, same thing. So this is 10,000 ohms of resistance. This is only 1,000 ohms of resistance. And if there's something that draws a little too much current for this one, where it pulls the voltage down, using a lower value Trimpot will help. It will be able to provide more current and hold the voltage a little bit better if the load is drawing current. Ideally, the load doesn't really draw any current, just looks at the voltage. So actually it's more of going to a sensor, something that senses the voltage, just like the multimeter. So again, we have the same thing. So we got the arrow there. The arrow's a little easier to see. It's almost all the way down, and so we go there. So again, it does not go all the way to the middle here. It kind of stops, looks like at that dot right there. And so you can get an estimate. We know that it's 5 volts, so we can estimate somewhere along the line from one dot to another. Let's go here. Hopefully that will provide about 3/4 of the power supply voltage. So just a tad bit less than 4 volts, I would guess. But it's that simple. These Trimpots or other potentiometers, there we go, pretty close to 4 volts. And a little less. So that's probably about 3/4 of the way from the negative rail. There is also a chance, maybe, let's go up here. You'll look at it from the positive rail, and then it'll be a negative voltage, which would be smaller because we're closer to the positive rail there. And there's other ways to look at it, but the main takeaway is you have a voltage across it, and at the output here there's 3 metal pins. At the output here you get a fraction of the voltage depending on how far along it is with the wipers. So the same thing was with the fixed resistors, but they have set values, and so you can't adjust them. These you can quickly adjust, and ultimately the actual resistance does not matter at all. The only thing is a higher resistance will let less current through, so it's easier to knock off that voltage at the output. If it's going towards the negative rail, whatever the load is, that will help push the voltage down. If it heads to the positive rail for whatever reason, that will help lift the voltage up at that point. So ideally, just like the multimeter, that does, it looks at the voltage but draws as little current as it can. That's why, so that it doesn't affect that voltage. So in any case, you don't really design circuits. I say this a lot in my videos because in the early electronics lessons that you learn about components and stuff, you don't really get taught how to use them in circuits. You get taught their properties. And then when you learn more advanced circuits, you already know their properties, and then you can see how they affect the circuit and how the circuit affects them. So learn about more circuits. Don't focus on individual components too much, but it is important you learn their basic properties so you understand how they affect other circuits that you learn about. So hope you enjoyed this video. Hope it was helpful. Thanks for watching, and I'll see you in the next video.